Good morning to everyone. In this lecture, EC8551 microprocessors and microcontrollers, the Unit 1 8085 microprocessor. In the previous session, we have discussed the architecture of 8085 processor and the pin configurations and the memory organization and the timing diagram of 8085 microprocessor. Now, here we are going to discuss about the interrupt of 8085 microprocessor. In this presentation, the interrupt is signals sent by an external device to the processor to request the processor to perform a particular task or work. These are the definition of interrupt signal. It mainly in the microprocessor based system in the interrupt are used for data transfer between the peripheral and microprocessor. The processor will check the interrupt always at the second T state of last machine cycle. If there is any interrupt, it accepts the interrupt and send the interrupt acknowledgement signal to the peripheral devices. What are the peripheral devices? The peripheral devices is nothing but external devices. So the vectored address of particular interrupt is stored in the program counter. The processor execute an interrupt service routine, that is a ISR, addressed in program counter, and it returned to main program by the reset instruction. Okay, these are the introduction of interrupt signal in 8085 microprocessor. Now we are going to discuss about the types of interrupt in 8085. There are two types. Number one is a hardware interrupt, number two software interrupt. Now we are going to discuss the software interrupt signals in 8085. The software interrupt signal or program instruction. These instructions are inserted at desired location in a program. The 8085 has 8 software interrupt from reset RST0 to RST7. That is a reset 0 to reset 7. The vector address for these interrupt can be calculated as follows: the interrupt number into 8. So the interrupt number into 8 is equal to the vector address. Now we are going to reset 5.5 into 8 is equal to 40. That is a value of 286 H. This is a vector address of RS 5.5 into 8 possible vectors. So the vector address of all interrupt, we see the block diagram. So the interrupt and the vector address in the reset 0, that is a vector address of 000H, and the reset 1 is a 0008H, and also the second column is a reset 2 0010H, reset 3 is a 0018H, and the fourth column is a reset 4 0020H, reset 5 is a 0028H, and finally the reset 6 is a 0030H, and reset 7 is a 0038H. These are the vector corresponding vector to the priority interrupt level of the 8085 microcontroller. Now the next one is what is a hardware interrupt. An external device initiates the hardware interrupt and placing an approximate signal at the interrupt pin of the processor. If the interrupt is accepted, if the interrupt is accepted, then the processor executes an interrupt service routine. So the 5 category of we are dividing the hardware interrupt. Number 1 is a trap. Number 2 is a reset 7.5, a reset 6.5, a reset 5.5, and finally interrupt request signals. So in the trap, this is a interrupt is a non-maskable interrupt. It is unaffected by any mask or interrupt enable signals. So trap has the highest priority and vector interrupt. So the trap is edge and level triggered interrupt. We are discussing the edge and level triggering interrupt is one of them to resolve the priority level of the each individual functioning blocks. This means that as trap must be go to high and remaining high until it is acknowledged. And now in sudden power failures, it execute the ISR, that is the interrupt subroutine, and send the data from the main memory to block backup memory. So the signal which override the trap is hold signal. Therefore, if the processor receive the hold and trap at the same time, then the hold is recognized first and then trap is recognized. Now there are two ways to clear the trap interrupt. One way is by resetting the microprocessor, that is the external signal, and another way by giving a high interrupt acknowledgement signals into the internal processor. Now we are going to discuss the reset 7.5. The reset 7.5 interrupt is a maskable interrupt. It is a second highest priority of interrupt signals. It is a edge sensitive, so therefore the input goes to high and no need to maintain the high state until it recognized. And the maskable interrupt, it is disabled by DI interrupt system or processor reset after the recognition of interrupt enabled by the EI, that's the enable interrupt instructions. Now the reset 6.5 and 5.5 is the same, acting as a 8085 microprocessor. The reset 6.5 and 5.5 are both are the level triggered. Okay, so therefore the input goes to high and state high until the recognition. The maskable interrupt is disabled by the destination index and the SIM, that is a destination interrupt and serial input memory instructions. So the second one is the system or processor is resetted. Third one is after is recognition of interrupt and enabled by the external or enabled interrupt instructions. The RST 6.5 as the third priority, whereas RS 5.5 as a fourth priority. The interrupt request is a maskable interrupt, so it is disabled by the DI and SIM instructions. So the system or processor reset conditions after the recognition of interrupt, it enabled by the EI instructions. Now the non-vector interrupt, after receiving the interrupt acknowledgement signal, it has to supply the address of interrupt service routine. It is one of the lowest priority. What is the lowest priority? The lowest priority of 5.5. So it is a level sensitive interrupt. Therefore the interrupt goes to high and it is necessary to maintain the high state until the recognized in 8085 microprocessor. Now the following sequence of events occur when the interrupt request signal goes high. Number 1, the 8085 check the status of interrupt request signal during the execution of each instructions, right? So the next conditions, if the interrupt request signal goes to high, then the 8085 complete its current instruction and send the active low interrupt acknowledgement signal if the interrupt is enabled. And in the response to the acknowledgement signals, external logic plays a interrupt opcode on the data buses. In this case of multi-byte instruction, additional interrupt acknowledgement message cycle are generated by 8085 to the transfer the additional byte into the microprocessor. And finally the interrupt request signal goes to high. So the on receiving the instruction, the 8085 save the address of next instruction on stack and execute received instructions. Now we are going to discuss the SIM and RIM for interrupt, SIM and RIM for interrupt signals. The 8085 provide additional masking facility of 7.5 and 6.5 and 5.5 using these interrupt signals. So the first SIM instruction, the status of this instruction can be enabled, can be read by executing the RIM instruction. The masking or unmasking of RST 7.5 and RST 6.5 and RST 5.5 interrupt can be performed by moving an 8-bit data accumulator and then existing the SIM instruction. We considered the 8-bit data to be loaded into the accumulator sessions. So the D0 to D7, these are the number of register bank in the 8085 processor. Now the M5.5, M6.5, M7.5 and MSC, so maskable enabled and maskable reset RST 7.5, and the SOD is a serial output data and the serial data enable signals. We are distributing the interrupt signals by reading the executing of the RIM instructions. Now the unmasking of the reset signals providing move to 8-bit data to the accumulator sections. So next one, the status of pending interrupt can be read from accumulator after the executing the RIM instruction. When RIM instruction is executed and 8-bit data is loaded in the accumulator, which can be interrupted in shown in figure. With this figure, it shows the 8-bit data is loaded in the accumulator session, the same data bank memory bank to the LSB side and MSB side. Then LSB side mask status of the RS 5.5, 6.5 and 7.5 signals, and this one the more MSB side is the serial input data. Next one is interrupt pending, interrupt not pending signals in the 7.5, 6.5 and 5.5. So in this session we are discussed in the interrupt of 8085 microprocessor. Thank you for watching this video.